So this project lasted 3 years. It was about the aromatic diversity of Italian white wines. So there will be a number of presentations because we have dealt with different topics as part of this project. The starting point was chemical categorization, and then we defined some volatile markers and we classified their sensory impact. My name is Maurizio Iani. I'm from the University of Verona, and I was the coordinator for this project. This project included many entities with researchers from different research centers, from Naples, Verona, Turin, Padua, Bologna, Trento, all universities. And you will have the opportunity to listen to different presentations from different entities. Professor Parpinello can't be here with us today because she comes from the region which was flooded yesterday, so it will not be possible to present the results of her research. So, what have we done? This is the PRIN call for proposals from 2017. This project was funded by the Ministry of Education. DWines stands for diversity wines, diversity of Italian wines. We have created a mapping about chemical composition and sensory quality of the main Italian wines, and we know that we have so many appellations in Italy. It's been said several times there's a strong connection between terroir and varieties. So DWines as a group was set up for a project which was funded in 2015. 6 research centers were present, and this project was about the tannin content of the main Italian red wines. So what were the chemical characteristics of those wines and what was the phenolic composition? This project was presented in 2019 at Enoforum, and we focused on astringency, while this year the group includes 7 research centers and we focused on white wines. We chose an aspect that is strictly related to quality, sensory characteristics, specifically aromas, and you can see the wines we focused on. We chose those wines not only because of our preferences, but also because of the availability of different samples, because we used commercial wines. So we partnered with wineries and we obtained a set of wines. Different regions were included, each region with a number of varieties, and here you can see the number of samples we collected from different wineries. For instance, Ribolla Gialla, 14 samples from 14 wineries. All wines, same vintage, they were packaged at wineries, they were sent to research centers, and then we dispatched them internally so that each research center could rely on the whole set of samples. So this is the project, and you see some exceptions here. So what did we do? The different research centers, the different labs received the samples, and these are the parameters that we assessed based on the expertise and skills of each research center. We combined different chemical parameters and different sensory parameters. We are not done yet. The project was extended until the end of the year. Some data still need to be processed. Data are quite complex. You will hear some presentations today, and there will be some surprises in relation to the characteristics of some wines which might be known locally, but they were not widely known in terms of their features, and this is what we'll be doing today. This session includes 3 subsections. The first subsection concerns the composition of these white wines, which attributes are distinctive. And after my introduction, there will be a paper about sulfur compounds, then a specific marker, methyl salicylate, and then we'll talk about terpenes in isoprenoids, and then we'll talk about macromolecular composition. Second subsection will concern the technological aspects of the varietal identity, so fermentation, volatile compounds, and what is the relationship between these compounds and the identity of Italian varieties. Then a presentation will be about the evolution of the aromatic profiles of these white wines, what happens to the aromatic profile when wines are stored, and then another aspect, the bentonite-based treatment, so what happens to these traits. And then the last part is the most interesting, but can you actually tell that these wines are different in terms of their sensory identity? So there will be a presentation about the sensory identity of Italian white wines. There is another paper which is very interesting because it makes it possible to analyze these aromatic profiles, but this last presentation will not take place because Professor Papinello can't be here with us today. So this is our agenda for this afternoon. Hopefully you will find it interesting. In terms of questions at the end of each presentation, there will be some time for questions, and then there will be a final Q&A session. I think that this is it for my general introduction, and I'm going to give the floor to our first speaker. So, Professor Mattivi from the University of Trento, please take the floor. He will talk about sulfur compounds. Good afternoon, ladies and gentlemen. There are still 90 people here with us today. I'm so happy. When this project was started, there's something we realized from the very start. There are hundreds of studies that compare the different characteristics of specific varieties, but we lack objective tools that make it possible to understand what is really peculiar about a variety, how a variety stands out, how it is different from other varieties, and which are the traits that can be identified analytically, and what are the traits that can be perceived from a sensory point of view, and how can they be communicated to consumers. At the end of the day, we like to talk about our varieties with an in-depth approach. Specifications are not enough to describe a wine. There's a final workshop about sensory charts, which is very interesting. Very briefly, as for soulful aromas, these topics was dealt with in this open access article. A number of protocols was created to analyze the varietal traits, and Sauvignon Blanc was specifically analyzed, but we have lacked reliable methods for years, so we haven't had any reliable information and robust information for years. And these traits are semi-ubiquitous, so these traits are varietal. These precursors are present in grapes, but they are expressed only after a specific decision is made by the winemaker. So this conference is about winemaking, and I assume that you know that there's a very important aspect of the raw materials, but there's another aspect that concerns processing, how raw materials are processed, and processing methods are different today compared to 20 years ago. So the data will present the results of the varietal characteristics that are expressed in commercial wines. Some of them may be replicated, so a variety has its own traits, but it should be processed consistently. So if you buy commercial wines from different wineries of the same local area, you can find some consistency. In terms of analysis, I will not elaborate on it, but this method is based on liquid chromatography that gives you robust data so that you can create a reliable data set. I think that this method will be used in the future as well, because now we have consolidated data. The samples were described by Professor Uliano, so 246 wines. So we selected the most representative wineries. Most of the wines we selected received important awards internationally. This means that we chose reference products, As for Müller-Thurgau, we found specific traits, specific characteristics, and we wanted to understand whether they were strictly related to the local area in Trentino or not. And so this is why we selected several samples from other regions as well and from other European countries. The first compound, which was industry, is the 4-MSP, which is a compound that gives the cat pee aroma. This compound has a variety with higher values. You can see some box plots here, and the horizontal bar related to the median value. You see the upper and lower limits, 25 and 75% of samples, and the two whiskers related to the distribution up to 95% of samples, and there are some abnormal points compared to normal distribution. The distribution of values of 4-MSP is specifically relevant in Müller-Thurgau. Then 3SH, this is associated with tropical aromas like passion fruit. And in this case, there's Lugana, which stands out because its medium values are higher than other varieties, and Verdicchio. And their median values are higher, and their distribution is quite homogeneous. So most of the samples have significant values beyond the sensory threshold, but there are high values in the other varieties as well. This means that this is not only a varietal compound, it is a technological compound as well. A specific approach to protect against oxidation and reduction is essential. The role of yeast is very important, so other varieties might have higher values depending on the winemaker's choice, but for some of these varieties there's a combination of an appropriate amount of precursors, and winemakers have adopted a consistent approach. Lugana and Verdicchio are similar, even if they are grown into different regions. So it is the varietal component that stands out. As for the third compound of this family, 3SHA, values are quite low. The average is slightly above compared to the others, only for Lugana, Müller-Thurgau, Vermentino and Verdicchio. This compound hydrolyzes quite quickly, so there might be bigger differences. As for Müller-Thurgau, the profile is quite peculiar because there are some values above threshold of the main compound, 450 or 500 nanograms per liter, up to very significant values, but it is always above threshold. And the 4-MSP is always above the threshold. And this expresses a specific trait, elderberry. Here you see some data from the sensory panels, one in Naples and another one in Bologna. Results were consistent based on sensory analysis of all wines and based on the correlation of the positions of samples in relation to the main components, and based on the values of the different samples, you can see that wines that are in the right hand side for the first component and with negative values for the second component have tropical aromas, passion fruit and cat pea, for instance, and box tree too. It is in line with the components that are being investigated. And we have the confirmation that some of the wines of the varieties we identified, Müller, Verdicchio and Lugana, tend to have impactful values. So once you define sensory charts with descriptors, you might say that these descriptors do work. And these varietal compounds were found at least in one sample of all varieties. This means that the potential is higher than the potential which is expressed today. And as for the 4-MSP, the only variety which is above threshold is Müller Turgau, and we consider the sampling of the must as well. Samples were taken randomly, but the trend was the same. So this is not a characteristics of Müller-Thurgau of that specific area which was selected, but it is a characteristic of this variety. As for the 3-ASH, it is ubiquitous in Lugana, Müller-Thurgau and Verdicchio. There's a huge variability that depends on agronomic and technologic aspects, so the vinification methods, yeasts and stoppers as well. So these elements play a very important role in keeping the levels of these compounds, which are highly sensitive, and they're sensitive to oxidation. So this is the very first part of this project. Then there's another project about sulfur compounds.
Grazie professor Mattivi per la panoramica, ho cominciato a vedere, quindi grazie.
Thank you very much. Thank you very much for providing us with this beautiful overview of the topic. And please keep the slides that were on, because I need the 3 ones that are about to come. So sulfured compounds. Of course, we needed also to consider the reduction component, that is the family of sulfured compounds that we call low boiling point compounds which are linked to the fermentative mechanism and which are rather ubiquitous. We also have a dimension which is linked to a number of chemical reactions so that they accumulate during fermentation. They are clearly the typical H2S and methyl mercaptane with the classical reduction odors, a rotten egg, and sulfurous odors. In general, we attach them and relate them to negative odors, and they can also contribute, though, to the complexity sensory perception. H2S, again, these are ubiquitous compounds. They are present at least in one sample of each and every type of variety that we analyzed. Here, concentration often exceeded the threshold of perception. And should we tell, for instance, that that specifically category of wine is marked in general due to the accumulation of H2S, of reduction odors, well, we would say a lie in that we did not observe that. Then methyl mercaptane, there is a slightly higher threshold than H2S. And you see that there we started making a number of observations whereby you can segment the types and varieties. Müller is again characterized by the presence of sulfured compounds. So there is a certain amount of them in Gewürztraminer, but Vermentina cortese and Pinot Grigio also have a slightly higher than average quantity of these compounds. Of course, there are distinguished features. In the Müller-Thurgau sample, there is a higher quantity, that is for sure. So, again, there are differences from one variety to the other, but there is a pattern. There is another compound that we should mention with reference to that, and we will talk about that more extensively later on, but it is DMS, dimethyl sulfide, and it is characterized by above threshold quantities. Here we have notes that are reminiscent of asparagus and then cooked vegetables and truffle also, especially in red. So you see that Greco di Tufo stands out in terms of the higher content in this molecule, and this is also something which comes up with aging, which is a varietal feature. To conclude, we can state that we observed a number of varietal pattern, less marked possibly than what we saw earlier on with Professor Mattivi, but especially DMS seems to be a discriminating compound, and methyl mercaptane also to a certain extent. We will go back to DMS later on, so we will integrate that with the contribution we want to make about the aging of wines. Thank you. We now continue with the contributions, and we are still addressing varietal compounds. There is one molecule especially that emerged as a very interesting marker, which is also very distinctive, which is methyl salicylate. Methyl salicylate.
Chiediamo in regia, ci sono già delle domande? Ce ne sono? Ok, allora le facciamo ora, dai. No, appaiono?
Well, there are actually a couple of questions before we move on.
Rispondere io alla prima.
I'll try and answer the first one. The first question is, have you considered the possibility that wines are not 100% coming from one variety? The answer is yes. As said at the very beginning, we worked with a number of estates that we know, and so we asked them to supply us with samples that are as representative as possible of the variety or of the appellation or designation. But you know that designation can also entail that you add wines from other varieties. So it is not so that in general these wines are single variety wines, but we focused on the single variety in the samples. We wanted to have a mapping that could be related to the actual situation of marketed wines, and we made reference to the estates that represent those varieties. So we tried to take the samples that are in line with this approach. We did our selection. That is the answer. We discussed at length about this also internally, so thank you for your question. Clearly, we had doubts about this. And one of the reasons why we did a second sampling with Müller is related to that. For instance, we considered why Müller-Thurgau had that above threshold quantity, and you see the profile is diversified in order to get to the elderberry flower note. You should have a different blend theoretically. And so also considering Sauvignon, we had evidence from the market of the opposite situation. So we decided to sample again, and then boxwood. There you exclude outliers, and I tend to think that a number of outlier samples have been adjusted because following rules you can also use highly characterizing varieties, and we need to consider that. What you said, Fulvio, is very interesting, because in this project, we considered what you said. Going back to the Müller-Thurgau, something emerged during the first sampling, and then we investigated that further. It was 50 wines or so, if I'm not mistaken. It was a distinguishing, discriminating feature at the first sample. Then we investigated it further, and that confirmed the first outcome, which means that broadly taken, the elements that we accumulated and detected were then confirmed by sampling in different vintages with broader samples and so on and so forth. So I would say that this is representative of a varietal fingerprint. For sure, a number of aspects should be considered while bearing in mind that it is not only a variety which is represented, but also designation. Have you observed variables shared by wines which are highly thiolic? The answer is no. We did have metadata on samples and on vinification, but we did not manage to relate back to the high content in thiols to one variable which proved to be highly distinctive or distinguishing. Clearly, as Professor Mattivi said, there are several components that come into play: yeast, fermentation, nutrition, agronomic practices, and the like. So that is clear, but variety was the strongest component. Both in Verona and at the MAC Foundation, studies had been done on Lugana and Verdicchio, and this partially thiolic character of those varieties had emerged. So this is something that comes up in different studies and scenarios. And then you have to consider the enologies. The gentleman should kindly speak in a microphone because he's not using a microphone. Kindly ask to use a microphone because the gentleman is not using a microphone. I wouldn't say that the difference we found in Verdicchio and Lugana are varietal. They are distinguishable, but the key information is that when you combine with technology, you have above threshold values, and then, of course, there is the decision of the enologist. It is a choice of style, so to say. How do you select wines that are representative for the analysis? I'm not so sure I understand this question. If you mean how we picked the categories we should investigate, well, the answer is that different things were considered. They should be representative of production in Italy. They should also be associated in general to certain characteristic profiles of aromas. And then we also considered the possibility of working with estates and producers that we already knew and that we had worked with. In a number of cases, consortia supported us, and the same applies there. So we picked those that we knew already, because we wanted to be sure that what we used came from reliable producers that understood what we needed. So we have a number of things here, chemical aspects, and then operational aspects and practical aspects as well. There is yet another question. Is it realistic to, or non-realistic, to think of a characterization as a routine which would accompany tasting tests for DOP certifications? Well, I will try and provide an answer, but we should possibly keep this question till the end of the session. If we consider sulfured compounds, again, they are to be found everywhere, with peaks in Müller, Lugana, and Verdicchio. But otherwise, it is rather difficult to discriminate based on that. Then there are additional layers, being compounds or families of compounds, which make up the variety distinguishing feature. And that is one thing. And we know that. But how many types of analyses and methods have we applied to finite element analysis, to FEMS? So all in all, 7 methods, and then the volatile fraction, the non-volatile fraction, polysaccharides, so many things. It is very difficult to be able to think that you routinely go for this set of analyses. And the reason why there is a group of universities contributing to this project is that it is fairly complex analysis, and different research groups are experts in different things. So you can hardly imagine that one center only boasts all the expertise which is needed to make the analysis, to detect the concentrations of a few nanograms per liter. So again, I can't possibly imagine that this really becomes a routine. Of course, in the future, we might go down to a subgroup of factors, and that would simplify things. Now, we move on to the second contribution with Dr. Silvia Carlin, who will address us on a very, very interesting molecule. Thank you. Another molecule we worked at in San Michele all'Adige is methyl salicylate, which is an ester, and it is very interesting because it has this balsamic odor. The threshold, the olfactory threshold is 38 micrograms per liter. It is a highly versatile molecule because it is highly present in nature, and it performs several functions. We find it in Gaultheria procumbens, and it is from the leaves that you can extract by distillation the so-called wintergreen oil, which is a highly balsamic menthol substance which you use for massages. It is grown in Canada, and it is used to make tea, which is drunk, obviously, and which performs calming effects. And it has an effect like aspirin. It is also involved in the mechanisms of the defense of plants against biotic stress. If a plant, as you see here, is attacked by pests or predators, it produces MS as a defense mechanism. In Bordeaux, they analyzed that for the vine, and you see wine coming from grapes, from vines attacked by fungi, had a higher content in methyl salicylate, because that was a stress response mechanism. It is used especially in Chinese medicine. There is a lactoside, glycoside, and lactose, which has been used for centuries now in Chinese medicine to relieve muscle and skeletal pain. It is also to be found in creams and plasters and several drugs which are used as painkillers. Professor Mattivi showed to me a picture of a dental product containing this, because it is extensively used in dental products. It is highly odorous, as we said, and it is especially found in the form bonded to glycosides. The plant binds volatile compounds. We know that, and we found that in terpenes, and it binds them to sugars for a detoxifying effect, because phenols and terpenes are toxic for plants. For instance, when there are wildfires, and so there is this binding to sugar mechanism that comes into play. Plus, this happens to make them more stable. In nature, we do have this. When we started studying the MS, I read this review by a Chinese researcher. There are 9 possible binding pathways for plants. In red, you find what was found in grapes as well. And the original method studied by Bayonov in the 80s is hydrolysis, both enzymatic and chemical. But you see the free compound, not its origin, with that method. What we did was to go for a different way, a different method, which is more demanding, because glycosides are not so often to be found on the market. This is a commercial product. This is bonded to glucose, and then the same goes for rotinoside. The others were isolated thanks to the contribution made by Domenico Masuero. I said we isolated them from plants where there were glycosides and also, for instance, violutoside, which was found in Viola tricolor, so much so that we made an extraction. We used a spectrometer, high-resolution spectrometer, to make our analysis, and we found a correlation, and the same goes for the other compounds that you see on the slide. Again, in red is what can be found also in grapes. Over the past years, much has been written on this. This is a work by Professor Darrier, and we saw a correlation between methyl salicylate and other plants. And many papers were published, almost all characterized MESA in the free form or in the chemical or enzymatic form. In this work, we identified by a liquid method with high-resolution spectrometry the 6 glycosides in wine. Now, let's have a look at the project. As Professor Ugliano and Professor Mattivi said, we have a fairly wide-ranging data set, and we have from 8 to 18 samples for each and every variety. It is a simple, straightforward method, provided you have the right method, because filtration is made, and then a mass analysis is made with liquid separation. Let's see what we found. In line with the previous work, we evidenced there that the total glycosides show that a number of varieties have a higher quantity of methyl salicylate, and we have Lugana, Verdicchio, and Erbaluce. Lugana, Verdicchio are kins. A number of farmers from Veneto during the pest plague moved to other places, and the Lugana Soave became Verdicchio. Then other glucosides. This is the single glycoside and the diglycoside. And again, the same 3 varieties emerged. The sum also, or the other form, did not entail any difference. Now, Primaveroside, again, same picture. Lugana and Verdicchio stand out. But consider violotoside, where you have also Cortese and Garganega emerging. And it is so that in the regulation permits also to use those 2 varieties. And then in rutinoside, we also have RNase featuring the compound to a larger extent. Gentio biocide seems to be more characterized. The free form of methyl salicylate, which was studied, showed that the vintage we used was not the best one. We are having values here which are below the threshold, and if we consider the ratio between the free and the glycosidated form, we have the average that was put on the slide. What did we want to understand? Well, we wanted to see how glycosides evolved during aging. Dr. or Mr. Luzzini, in particular, carried out an accelerated aging experiment where 6 samples were picked for each variety, and in absence of oxygen, they were kept at a temperature of 10, 40, 60 degrees for 1 month, and then we repeated the analysis. We see that the difference between aged wine and the control at 40 degrees is very limited. In a number of cases, actually, we have a reduction in MS because it is degraded down to something else, as Slagen-Alfie also evidenced. On average, in the richest cases, we can have a release of 5 micrograms per liter. 60 degrees then, there the situation is slightly better. And in varieties with a higher content, we can have a release up to 10 micrograms per liter. The olfactory threshold is 38 micrograms per liter. But there are works, especially in wine, in cherry wine, that show that also under the threshold you can have a fruity note, which is particularly interesting for wines. And now we tried to correlate the total glycosidic precursors and the MS that was formed. Indeed, this correlated with quite nicely, I mean. So we subdivided wines into 2 groups. One group with those that had a significant increase in the release of MS during accelerated aging, and those which did not. And we saw that those with a significant increase in MS had a lower pH, which relates to the fact that the hydrolysis of glycosides is characterized by the presence of acid. Conclusions. In the Italian scenario, only 3 varieties stood out for a high content of this compound. Precursors of MS are higher, up to 1 milligram per liter, when compared to the free form. We confirm that Lugana and Verdicchio are the varieties with the biggest quantity or content, and also Erbaluce stands out in this respect. Then the most represented precursors are monoglucoside and gentiobioside, which is glucose-glucose. The ratio is 1:40, 1:50 in the bonded forms, and a bit lower in Erbaluce, Lugano, and Verdicchio. Over the course of time, if pH is low and the temperature is higher, there is a release of free MS, and this can play a role in favoring hydrolysis and the aroma of aged wines. This has been published in Eno1. The first name is Maurizio Piergiovanni. You see, I would like to thank him very much because he has worked so much with us and so hard, and without him we would have never obtained these results. Thank you very much for your kind attention. Thank you, Silvia. Other questions?
Ecco. Allora, essendo i vini tutti della stessa...
Since wines are all from the same vintage and the molecule is a response to stress, could differences relate to different pathologies? Well, we saw that a number of varieties always showed a richer content. Others did not. So it might be that there is also biotic stress involved, but we did not investigate that specifically. Also because Darier's work was published after we had done our analysis. We could consider that, and the same goes for the action of enzymes. We heard how useful they can be for the hydrolysis of compounds, and we only went for a chemical hydrolysis over the course of time using temperature, and using that could help release this reserve of precursors. If I may, I would like to add about pathologies that in Verona, For several years, we have been making some analysis on samples of Lugana, and that is obvious due to our geographical location. And we think that this molecule is distinctive of this variety. We see that the quantity which is present in wines, with a concentration in wines in various and different vintages, varies. 80 to 100 micrograms per liter were found in certain years in samples. So probably there is also an effect linked to the disease, to biotic stress. But again, it is a varietal characteristic that we can speak of in this respect, and this certainly goes for Verdicchio. So no further questions. So we move on, and we now change topic a bit and address more traditional aspects. We have two families of molecules which have always been considered protagonists of the scene: terpenes and norisoprenoids. From University of Verona, Giovanni Luzzini.
Good afternoon. As you know, terpenes are varietal compounds which can be classified in terms of their aroma contribution and biochemical composition. We have monoterpenic alcohols that give floral notes. For Moscato, cyclic terpenes, resin, wood, and then bicyclic terpenes, mint, eucalyptus, and herbs. Terpenes accumulate during maturation both in pulp and skin through two metabolical pathways, the mevalonic acid and 2,C-methyl-D-erythritol. As for norisoprenoids, two different biochemical classes. They are related to two different aroma categories: tobacco, quince, camphora, and norisoprenoids accumulate during maturation because of the degradation of carotenoids. Terpenes and norisoprenoids accumulate in grapes during maturation, and they are released during vinification. Is it easy? It is not, because the scenario is much more complex. There's a number of variables that influence both content and profiles of these compounds, specifically yeasts that can influence precursors, and it can transform some terpenes, and it can trigger absorption phenomena. There's a very important effect of acids. Acids can influence a number of reactions: hydration, dehydration, and cyclization, and then there are some effects related to geographical origin, climate, and practices in the vineyard and in the cellar. The scenario is quite complex. What is the object of our section of the research? Characterize the terpene and norisoprenoids profile in several white wines, Italian white wines. These are the first results we've achieved. One of the appellations we studied is Gewürztraminer, which is an aromatic variety, and the content of total terpenes is quite high compared to the other varieties, specifically the linear and cyclic terpenes, and for these reasons, during the other comparisons, we decided to get rid of this parameter in order to make the most of the differences between the other appellations. And then it is characterized by this marker rose oxide that is present only in Gewürztraminer. The previous speakers found another difference. Gewürztraminer showed differences in terms of total terpenes up to 22 times between the different Gewürztraminer. So let's go back to the comparison. And we got rid of Gewürztraminer. The appellations with the highest content of total terpenes are Cortese, Falangina, Müller, Torgau, Nosiola, and Vermentino. And here you see the varieties with the highest concentrations. As for Gewürztraminer, we found another intra-appellation difference in Vermentino. There are concentrations from 20 up to 100 and 200 micrograms liter. Now let's focus on each compound. Linalool. This is the most well-known terpene, and it is found in high concentrations in all varieties, and the profiles are quite similar to the previous chart. Cortese, for instance, Müller-Thurgau and Vermentino. And as for the olfactory threshold of linalool is 25 micrograms per liter, and for some appellations, specifically Vermentino, concentrations are higher than the olfactory threshold, so the aromatic contribution of this molecule could be quite significant. Another terpene we found in high concentrations is beta-citronolol, and the richest varieties are Nosiola and once again Vermentino. Let's move to cyclic terpenes. Alpha-terpineol. This is a cyclic terpene that smells like resin, and we found quite high concentrations, and the appellations are similar to the total terpenes, but there's another appellation, Fiano, and so far not many terpenes were found in Fiano. Another cyclic terpene is terpenen for all, and as you can see, partners are different. If we get rid of Falangina and Vermentino, whose concentrations are high, we find Fiano again, which had high concentrations of the other cyclic terpene, and Lugana and Verdicchio feature good concentrations. As it was explained, the variety of these two appellations is the same, Trebbiano di Soave, so this is why they behave similarly. Then 1,4-cineol, this is a bicyclic terpene, aromatic herbs, and the perception threshold is quite low, 0.63 microgram liter. It is quite powerful, and some varieties didn't show a high concentration of total terpene, but they feature a high concentration of this terpene. We considered Gewürztraminer as well because it features concentrations which are similar in terms of bicyclic terpenes, and we found that Erba Luce features good concentration, Fiano, Lugana, Verdicchio, and Vermentino too. And some wines feature concentrations which are above the perception threshold. Almost a half of Gewürztraminer samples and 25-35% of Verdicchio wines. Then we consider 1,8-Cinyl eucalyptus. It is called eucalyptol, and the perception threshold is quite low, 1 microgram liter, and Gewürztraminer, Cortese, and Vermentino feature the highest concentration, and 25-35% of Gewürztraminer wines show a concentration which is higher than the perception threshold. In terms of the total norisoprenoids, Müller-Thurgau, Nosiola, Vermentino, and Vernaccia showed the highest concentration. The norisoprenoid that shows the highest concentration, even if it is far from the perception threshold. TPB is TPB. No, sorry, this is Vitispirane, and the patterns are the same as the total norisoprenoids. Müller, Nosiola, Vermentino, and Vernaccia show the highest concentration. Then let's move to TDN. This is a well-known norisoprenoid because of its kerosene notes. This is typical of Riesling. The perception threshold is quite low, and most of the wines show a concentration above the perception threshold, but the appellation with the highest concentration was Vermentino. All wines showed a concentration beyond the perception threshold. The TPB, another norisoprenoid that smells like tobacco, two different behaviors. A number of appellations show high concentrations, and a number of appellations that show concentration next to the perception threshold, 0.04 micrograms liter. The last norisoprenoid that we considered, beta-damascenone and quince. This is the note, and it boosts the fruity parameters, and the patterns of appellations are different compared to total norisoprenoids. Arnese, Falangina, Fiano, Gewürztraminer, Nosiola, Ribolla Gialla, and Vermentino showed the highest concentration. And before moving to my conclusions, I like to focus on Vermentino. As you realized, for most of the compounds, there's a high variability in relation to Vermentino, not just in terms of concentrations. So Vermentino has high concentrations both of terpene and norisoprenoids, and if we consider Vermentino number 1, 2, 13 and 14, we see that these wines are quite different. Vermentino 1 could be a neutral wine. Number 2 smells like kerosene and tobacco, and number 14 has floral notes. So within the appellations, we identified some trends, and Vermentino shows high concentration of both terpenes and isoprenoids. Based on these data, we built up these radars, and we consider the different biochemical classes of terpenes and isoprenoids. These are sort of fingerprints of the varietal profile of terpene and isoprenoids, and despite the higher variability, you can see the different distinctive varieties, even if there are some similarities between Lugana and Verdicchio, which are characterized by bicyclic terpenes. I like to wrap up. Gewürztraminer is an aromatic variety, and it shows high concentrations of linear and cyclic terpenes, and there's a high variability within each variety for both compounds. Vermentino is rich in terpenes with concentrations that are above the perception threshold. Cortese, Falangina, Müller-Thurgau, and Osceola showed high concentrations of terpenes compared to the other appellations, and Fiano showed a low content of total terpene, but it showed a high concentration of cyclic and bicyclic terpenes, while Verdicchio and Lugana show a high concentration of terpene 4-ol and 1,4-cineol. Linalool, 1,4-cineol, 1,8-cineol were found in a concentration that contributed to the perceived aroma. Vermentino is rich in isoprenoids together with Vernaccia, Müller, Osceola, and Arnaz, Valangina, Fiano, and Ribola Gialla showed a high content of beta-massenone. Beta-massenone, TDN, and TBP were found in high concentrations so that they can be perceived in most of the wines. Thank you.
Grazie al dottor Luzzini.
Thank you, Mr. Luzzini. Maybe some questions from the audience?
Nessuna, ok.
No questions. Thank you, Giovanni.
Ora procediamo con l'ultima relazione.
We now have the last contribution for this module, which is about varietal compounds in white, and the speaker is Matteo Marangone, and here we will set aside aromas for a moment and focus on macromolecular composition of white. Well, thank you for giving the floor. Thank you to those in the audience who are still here. I will speak about micromolecules. I will briefly address you on macromolecule and tell you what they are. In white, we have proteins, which are known to be able to cause instability. Matteo, we do not see the slides. Here they are. Here they are. I'm sorry. So, proteins in concentrations ranging on average from 50 to 100 mg per liter, polysaccharides 160 to 335, then condensed tannins 150 to 250. We specifically focused on the analysis of proteins in whites. It is proteins from grapes, which are PR proteins, chitinase, and tomatine, similar proteins. They survive vinification very well. They are present in the grapes, and they can also end up in the wines. Let's consider the impact in whites. So we have tomatines, chitinase, and beta-glucanase, which, technologically speaking, participate in the formation of colloids. And they also participate in colloidal cas, which means that bentonite must be used to remove them. Further impacts include turbidity, haze, the modulation of volatile aromas, and this is the reason why we speak about them in this session, because they can have an impact on the volatility of a number of molecules. From the viewpoint of spumante, well, they can stabilize bubbles, and they can also modulate the perception of body and astringency. Invertase, that is another protein. It is not unstable with heat, but it also participates in colloid formation. It is important in that it stabilizes the foam of spumante wines. It can modulate astringency and body, and lipid transfer proteins are very stable, and they can cause allergies. That is the only thing we can tell about them. The other class of compounds are polysaccharides, especially the soluble ones in wines. You see here all the sources and types. There are families of polysaccharides, and here you see that they can come from grapes, and they are rich in arabinose and the galactose, and then rhamnogalacturonans, manoproteins, that is from yeasts, chitin and glucans, and other forms as well, including gamma-rabic. Polysaccharides, let's see their evolution, their life cycle during vinification. During the decanting of whites and the clarification, part of them are removed, so the quantity goes down. In case of maceration, there is an increase in their content, in that they are more present in skins, and they can so pass into wine. During the fermentation, we have yeasts releasing manoproteins, and they enrich the wine with polysaccharides. With racking off, you have a removal of solids, and then they diminish. And if you have aging on lees, you have the autolysis phenomenon with an additional release of MPs. So the vinification phase is key in order to understand how polysaccharides behave. Impact, the PRAGs give problems with microfiltration. In sensory terms, they have an impact of viscosity and roundness and body of the wines. Then type 2, they do not interfere with filtrations, but they can reduce astringency in reds. The manoproteins are studied more, and they reduce the volume of microfiltration. They inhibit tartaric precipitations, and they also improve stability. In sensory terms, they are positive for the foam of spumante wines. They keep the bubbles stable, they contribute to body and viscosity, and they can also reduce the perception of bitterness in wines. Let's now consider the macromolecular part, and the goal of the project was that of considering the wines produced from 8 white varieties in Italy. The first type of analysis was analysis with the protein profile with HPLC, with the quantification of total proteins, especially TLPs and chitinase. Filtered samples were analyzed with HPLC. Each peak is assigned to a protein class, and then there is a characterization based on the underlying area. This is a sampling of wines that are bottled, finished and bottled, and which are stabilized. And despite this, we see that values are low. Palagrello in 13 samples, where we are below 3 milligrams per liter, and then Fiano goes up to above 20. So it is low values, but not that low. Average 8.3 milligrams per liter, a range from 0.5 to 59 milligrams per liter, with an average of 245 samples. And here, let's see what they are. They are almost entirely tomatine-like proteins, TLPs, while chitinase is almost absent because they are less stable when heated, which means that during vinification and preparation of wines for bottling, the chitinase has already disappeared. Let's now make a number of observations about the protein content of the samples. As I told you, in general, wines are stabilized and they are low in protein content. For a number of designations, it seems that their values are moderately high, though, which means a risk of protein instability, and that goes especially for Fiano. The more unstable proteins are almost absent in the majority of wines. We have tomatines only, and this is what is considered in terms of the possible presence of the colloidal cas on the wines. Now, a second set of data, which is highly innovative, is the analysis of the polysaccharide profile with IHRSEC, size exclusion chromatography. And there again, the samples were filtered, put into the machine, and then we analyzed the profile that emerged. With the chromatography, you see first the bigger sized molecules, and you identify peaks in that respect. For wines, methods have been developed, especially in Tarragona, Spain, where they characterized the classes of polysaccharides based on their molecular weight. 180 kilodaltons and above are classified at a high molecular weight polysaccharides, then to 40 medium, to 70.5 below, and beyond that it is oligosaccharides. Here we see results. The total polysaccharides, so the three first bars combined together, show that we have above average values for the whites when compared to what you can find in literature. In literature, you go from 150 to 350, normally 250 is to be found. Here, the overall average is 367 milligrams per liter, with a range going from 116 in one sample to one sample with more than 1.1 milligrams or 1,131 milligrams per liter, which is very much. In terms of varieties, and we will see that they will be mixed, but again, Gewürztraminer ranks first in terms of quantity, and Palagrello has less than all the others. And this is also linked to the style of vinification, whereby you can extract more or less vis-a-vis these molecules, as I showed to you in the first slides. If I now focus on the three different classes, high molecular weight, their Pinot Grigio prevails, and possibly the average also comes from the fact that one sample has a very high value, 400. Here on average 95 milligrams per liter vis-a-vis the previous value. It is 1/4. Then with the medium weight 138 with a very far-reaching range, and the Palagrello ranks last, Gewürztraminer ranks first. Once again, low molecular weight, 133 milligrams, very, very big range. And this makes us think that variability of these wines is actually very high, also when it comes to this parameter, which is partially linked to the style of vinification. So polysaccharides in whites in Italy seem to be higher, more present than what we find in literature, specifically compared to Spain and Portugal. A number of wines have very high content, more than 1 gram per liter, which is something that you have to investigate, because it can be that it is an additive which accounts for that. It is unthinkable that it is a natural thing only. There is a high diversity among varieties, especially in the range between the minimum and maximum levels, because the range is huge, as I showed to you. And then there is the varietal effect, which does not seem to be that evident, though, despite the fact that we always have the two Gewürztraminer on one edge, and the other one is Palagrello. But the style of vinification has an impact, and that can be typical for a style of wine, type of wine, and this means that these compounds are extracted to a higher or lower extent depending on the vinification, but this needs to be further investigated. The third type of analysis that we made is the assessment of the dimension of colloids. Here we have nanoparticle tracking analysis, which is used in our lab, and we can measure the average size of colloidal particles and see how the macromolecules aggregate and how they are in the solution. This is the output of the system. This is an analysis which is repeated several times. You obtain an average size. Here we go from 100 to 500 nanometers with various populations inside. I'm not focusing on each and every peak. I will rather focus on the average. And here we have 57 samples with this average. It is a complex analysis, though we focused on a number of varieties. We couldn't include the entire data set, but consider that the average of colloids has a size which equals 234 nanometers, which is something that another speaker will go back to. The range of wines, again, is huge. It goes from 140 to 442 nanometers. 9 samples of Vermentino were examined, and you see it ranks first. Then the majority of samples are around average, and Pinot Grigio has a smaller colloids. Conclusions, interim conclusions. The protein content of wines changes. There is a varietal effect, despite the fact that data are masked by stabilizing treatments. There are interesting trends, and they go back to Fiano with the 10-fold presence of proteins compared to Palagrello or Albana. Polysaccharides, there too we have a huge variation going from 250 to 450 milligrams per liter, which is almost twice as much. And there is an impact on stability, body, and the perception of volatiles. which makes polysaccharides important. We need to analyze clearly and carefully where we want to place ourselves on the spectrum. Then colloids, less variability around averages because stabilization and filtration techniques can also remove the larger sized colloids. In my second presentation today, though, I will go back to this with a number of data, and I will question this assumption. Anyway, the size is not correlated to the concentration in proteins and polysaccharides. You might think that there is a correlation, but there is not. So apparently there must be another mechanism behind this. In general, we can state that also for macromolecules there is a huge diversity in composition with repercussions for stability, body volatility of aromatic compounds, and this has an impact on the sensory outcome too. Then we need to try and better understand whether the diversity derives from varietal differences, climate differences, different vinification style, for instance, pre-fermentative maceration being included or not, or aging on leaves, and so on and so forth. So thank you very much, and I'm open to questions. Thank you, Professor Morangone. Are there questions? Well, two questions have been asked about the previous contribution, and this is the first one.
Possono incidono molto sul
And in terms of no-isoprenoids and terpene, can vinification technique impact the content? It all comes down to the geographical origin of the grapes. It is very impactful, and vinification practices are impactful, specifically the choice of yeasts and the capacity of expressing some enzymes, or the capacity of biotransformation impacts the terpene profile, and there are some wine pH modifying practices that are quite impactful. The starting point could be linear terpenes, and you could get cyclic terpenes, and pressing plays a role too. The scenario is quite complex and there are many influences.
C'era prima un'altra domanda, poi adesso mi sembra che è sparita, però se non sbaglio...
There was another question about the fact that fingerprints were presented, and as it was mentioned several times, these profiles refer to average trends on the most significant parameters. These profiles refer to a population of samples. These are just trends, so these are not profiles that are set in stone. These are just examples that represent the complexity of data